All right, I guess we're good to go. Oh, look at this. Thank you. Hi, everyone. How's everyone having a good time? The free drinks are pretty nice, right? Well, today I'm going to be talking about security automation in your continuous integration pipeline. Buzzword, 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 right? No. It's a little bit more than that. Developers are probably already doing this. Who am I? My name is Jimmy Bird. The slides are right here if you need to go get them. I'm a developer over at Binary Defense Systems. So anything that when you get these slides, anything that's orange is also clickable. So you can get my Twitter, you can get my GitHub, go to Binary Defense. So continuous integration, what is that? It's something developers kind of been doing for a little bit of time. If you've ever really worked in a development shop, you'll end up having lots of developers having to try to take their code and put them together. Apparently I cannot get close to that speaker, so I should probably stay away. All right. So developers will be trying to merge code together. Well, quote by Martin Fowler on what continuous integration is. Continuous integration is a software development practice where members of a team integrate their work frequently. Each integration is verified by an automated build, including tests to detect integration errors as soon as possible. So what does that really mean in layman's terms? Basically, anytime someone checks code into the source control engine, someone's going to pull down the code, going to run the build if you have a statically compiled language. If you have Python, you can't really do that, right? Python, Ruby, JavaScript. But you're going to take that, you're going to compile the code. If another system says you can compile your code, that's a good step. That's a first good step. Then, a lot of times, what you're going to end up doing is running automated tests against it. And so, you can run, we'll get a little bit into exactly what those tests can be, but you're going to want to run some tests against it, verify that, hey, some of these business functionality is working. Good. And this is really the reason why you want to do this is because how many times have a developer come up to you, it works on my machine? All the time. All the time. And this is to help prevent that. Because developers, we just like saying, yeah, it's good. It works on my machine. I don't care. I don't need any checks. It worked on my machine. Don't care. And so this is a simple version of continuous integration. It doesn't have to be anything super fancy. You just need to have someone that whenever the code gets checked in, takes the code, compiles it if it can, runs some tests against it, and gives you a report about it. Because that's what all you really need. You need to know whether or not that build failed or passed. And so this is basically what it ends up looking like when you try to merge code. Because it's hard. Merging code is hard, especially if you work on too many features at the same time. And working in very small individual features will help you prevent that, but we live in a society where that's not easy isn't always the answer to everything, and I wish it was. But so you want to be able to prevent some disasters happening when you merge your code. So you have the system that takes your code, runs the tests, gives you a report. And like a specific sample, something that would be at like work here, you run the build script. Did we restore all our packages correctly? Cool. How long did that take? Way too long because NPM is stupid. Then we, package our web assets, we do a lint on it, we'll compile the code, run our tests, and even scan the code, and that's what we're going to be talking about a little bit. Wrong way. And so some of the tools that you can actually use for the CI, continuous integration automation, tools like Jenkins, probably a lot of people end up using Jenkins. TeamCity is a good alternative, GitLab. And then there's open source alternatives like AppVay or Travis CI. So you can pull your just GitHub. If you have any open source GitHub repos, you can use like Travis CI or AppVay to go ahead and compile your code. And you can actually get a little badge on your GitHub repo that says, hey, this is verified that this code actually works. So testing. This is where developers we're starting to get better at this, but we haven't actually still done it as well as we should. And so we're getting better at the automated testing. And one thing that we should end up doing as we're at a security conference is actually doing the security testing. I mean, there's plenty of tools out there that are already doing this kind of stuff. Pen testers are using Burp. They're using Zap, Zed Attack Processing from OWASP. There's plenty of other source code analyzers out there, like Brakeman or the OWASP Dependency Checker, which we'll talk a little bit about those tools specifically. And those are going to help you get to the next level, letting you know what we're doing. But a lot of times, the tests that we write as developers are, hey, does this function work? Is this something that we think is good, like a business feature? Is it working? Cool. Who's writing the code to test whether or not you can actually authenticate and then change the query parameter and log into someone else? No one's writing those tests. And, that's why we have those other automated tools that can help us do those kinds of things. And so, why can't we do both, right? Why can't? Because we're already doing one, and a lot of people have already written code to do the other. And so, here's some more informational slides, so you get to see some of the hierarchy, Maslow's hierarchy of testing, really. Is you end up having some type of smaller tests that really test like individual pieces of your code. And those we're not really concerned ourselves today. Really, what we're going to be concerning ourselves really about is more the functional or web UI kind of testing. And what we want to get to is to be able to just submit our code, build it, run these tests, and also run our security tests. So I am obligated to put this in as a slide. I'm not going to read this to you, but what this basically is saying, I want to make sure my code is actually good and secure. I don't want to have attackers attacking my code. And I want to prevent that the best way that I can. Attackers going to get in, they're going to get in. I mean, it's hard, we all know this. That's why we're here, right? We're still at conferences. We're still having these problems every day in and a day out. And so what I want to do, though, is I want that I want to be able to secure my code. I want to learn to be able to make my code better. And so there's a project from OWASP, and if you're not familiar with OWASP, OWASP is the Open Web Application Security Project. They take lots of different approaches to web application security, just from information and even providing tools. Today we're going to actually take a look at one of these tools, which is called the Pipeline tool. Pipeline is really just a framework that allows you to commonly speak to other analyzers or security tools and give you like a way of commonly talking between them. And I'll show a little bit of the code in a bit about it. And so what you want to be able to do is say, hey, I want to run some of these scanners and get a consistent output. So I can put it into my task controls, which is like Jira or GitLab or even GitHub. And so these are some of the maintainers, and they have much better talks than I'll probably give today. So I recommend looking them up. I have some resources at the end to show you some of their talks as well. But there's 4 simple concepts when it comes to pipeline. You have mounters, tasks, filters, and reporters. Mounters is simply how do I figure out how to get the code into the program. And this comes in many flavors, like file system. I'll show it in a second. It's more about how to get the code in. Tasks are actually what you run against the code, whether it's a Zap or Brakeman or Linter even. Just what can you do? Filters is to help you prevent false positives or already producing the same result. So you already saw that this thing is vulnerable. We don't need to report on it again, kind of things. And reporters are really about taking that and putting it somewhere so you actually can use that information. So either putting out in just a text file, sending you an email, putting it in Jira, whatever your developers are using. And so what is in the box? For mounters, there's, like, you can use Docker, you can use the file system, excuse me, you can use the URL, you can use Git. It's really simple. It kind of figures out what you're trying to use, and it'll give you I'll show you in a second how to use one of these for, like, Git. Tasks, there's a bunch of these. This is just a smaller list, but I wanted to kind of give you a more a holistic view of like what's going on inside the box. So you have tools that will run against Ruby, Java, JavaScript, .NET, generic kind of tools, which is like ClamAV for like antivirus, fire integrative monitoring, Zap, which will be for your web application testing. So there's a whole bunch of these tools in here, and there's a few more that I did not list. Filters, these are kind of just for Jira, more or less to say don't report these again if you already see them. And reporters, you can either come out in terms of like CSV, JSON, text, or XML. There's a few more of these as well. So getting started, 2 ways you can grab this project. You can just install it as a Ruby gem, or you can install it through Docker. I recommend using it through Docker. The reason being, Docker will provide you a way to grab all of these tools in a. And if you're not familiar with Docker, it's kind of like a microkernel VM. Don't hate me because it's probably not. That's not exactly true, but it's like having a lightweight VM for your computer, and it'll download all those tools into a little box for you. So you don't have to go out and figure out where all these dependencies are. So it'll just take it all, grab you all in one. And so once you go ahead and get that, we can go ahead and see, oh, let's figure out the help. And you know what? I'm going to pull it up right over here. Or is this not like my terminal window? Maybe it does not like my terminal window. All right, there we go. One-handed typing is not fun, let me tell you. So, tons of information when you pull out the help file. And you can see as a help, it says, "This is a Swiss Army knife of security analyst tools." And so, here's like the hello world example that you can use to like kind of just give yourself some input and figure out what it is. I'm gonna run this. This will probably take a little bit of time. I'm not sure exactly how well the internet's doing here. So let's go ahead and run this. And so I'll go back to this slide really quick. So what we're doing here is we are running pipeline, and we're saying, go ahead and run this tool, retire.js, against this repo node-goat. And if you're not familiar with goat tools from OWASP, goat is a kind of a term for this website is vulnerable. And so they have goats in .NET, Java, right, this one specifically Node. And so you'll have different types of languages, and so you can explore, like, how should I defend my website with this language? And so specifically, this one is a Node website, and so what we're doing here is we're running retire.js. Retire.js is one of these tools that will go ahead and check all your NPM dependencies and figure out if they have any CVEs or other security vulnerabilities against them. And this will probably take a little while because there is quite a bit of tools in here. So I'll just kind of show you a sample output, and we'll come back to exactly to all the output once it's done. And so here's a sample output for our tool. And you can see that we have what the package that it came out to be. We have Uglify. Uglify is a package thing that basically takes JavaScript and minifies it. And it's saying it has a known security vulnerability. Oh, really? What is it? Down here you can actually read about the URL. It tells you exactly which the advisor is, but it's basically saying it has some type of, I think this one has like a regex vulnerability. And so at least you get a little output of saying, hey, this is a package that we have a problem with. So you have known that all your dependencies now have a problem, and you can actually have a good conversation. Here's an output for all of this, quite a bit of it. So I'll just start with like the top one here. So it's like, oh, jQuery. We know this jQuery 1.4.2. Why is it still being used in this project? I don't know, because developers think that we need to have old code because we update it, things break. But at least we know. You know, that's a thing. At least you know that there's a security vulnerability, and maybe it won't be doable. You know, maybe this is something that you can just start doing. What the people start evaluating risk. You can actually put this into your threat models, and so you actually know if the project could be vulnerable. It's better than not knowing, right? So there's a bunch of these like in here, like more jQuery. I don't know why we have a whole bunch of different jQueries. I don't know exactly what's going on specifically in this project, but we can see that we have a bunch. And so this gets me to talking about there's two different types of things in here. There's tools and there's labels. And so what you kind of want to do is look through the code. And what we can do, I'll kind of just scroll over to here. There's a folder. I already pulled down the code for us. And so we can look in the lib folder. There's a pipeline folder. And then there's those 4 concepts I talked about: mounters, filters, reporters, and tasks. If we look into the tasks, this will give us all the tasks. And these are basically just files that are implemented to basically call out to those tools like Brakeman or Retire.js or Zap. And so we could actually look at one of these files and say, okay, here's the name Brakeman, here's a description for it, and some labels. And so the reason I wanted to bring that up is you can actually, when we looked at our other example over here, we called out a specific tool we wanted to use. What you can use labels for specifically is to group them. And it's not obvious. The help doesn't give you a good list of these, and I kind of already done this for you. And so you can look, here's an example as well from Brakeman. And so what's important to note is the name without spaces is the tool, and the label is the label. And so a label is just an array, and so it'll be one of these various strings in there. But so what we can do is all the tools here are listed right here in this quick, easy dump that I have right here. And so you can, if you want to list Brakeman, if you want to list Bundle Audit for your Ruby stuff, or if you want to just go ahead and use Zap only, you can go ahead and use those. So an example is you want to use Brakeman or an ESLint, it'll run both of those together. Next one is labels, and here's a list of all the outpost labels. And so you can go ahead and say, I just want to run anything against Ruby. I have a Ruby project, it's Ruby on Rails, let's go ahead and run this. So you can just say -L instead of -T and specify one of these labels, and it will run all the things that are associated with that label. And so when we get into, if you ever get into wanting to create your own tasks, because you might be running something that's not in this list. The list is pretty heavily based in Ruby and JavaScript. There's no Python tools. If you want to write your own Python tool, it's really not that hard to figure it out because these are simple classes. They're really not that long. Basically, you just have to give it a name, a label, and how to shell out and how to take that data and actually print it out in a pretty format. Really not that difficult. But now you can actually group up and say, I want to run Python. I want to run JavaScript. Because if you're running a web application, you're probably going to have JavaScript. And so it's really easy to build your own tools. We could go through exactly these specific code examples. Let's see if I let's break it down a little bit easier to. That'll probably be easier to read. And so you just have to implement a few of these functions specifically in this class, which is initialize, which is the constructor for the class, and just give it a couple of properties. How to run the tool, you just need to implement that. How to analyze the results, and is this tool actually supported? And it's basically most of the time it's just return true. Not that big of a deal. And so that's really it for a task. So if you have another Python tool or a Perl tool or whatever you're running these days, you can go ahead and add this to your list. And so the first time you run this on your tool or in your code, though, you're going to end up with something like this. It's just going to be a giant list of stuff. And you're going to be like, I don't know what to do with this. This is going to be too much work. Well, just run one of the tools. See what's out there. You don't have to create an issue for every single one of these, but look at it. You have to do the research. Figure out, is this exactly something that's really a vulnerability in my software, or is this just something that's going to be something I could just say I'm accepting this risk? And so that's part of it, though, is just knowing's half the battle, right? You want to figure out that your tools or your software or whatever has vulnerabilities. It's better just to know that. And I'm not saying, because the thing is, these aren't going to fix your problems. Upgrading to the latest, you may still have a vulnerability. I don't know. And that vulnerability may be worse than the one that was in the previous. I don't know. But if those are reported, you can at least make a judgment call on whether or not to update dependencies or scanning your source code for hey, is someone putting passwords, hard-coding passwords, someone checking in our private keys into source control, because developers never do that. So at least these will give you a way of giving a conversation about how to fix these tools or fix these problems in your software. These tools can fix your problems in the software. And so these are some of the resources. as well. I'll go back to the beginning slide so you can actually see the link, so you can go ahead and go grab these slides. And these are all the tools. There's some talks better on how to do more conceptualized. This is kind of just to get you an intro into figuring out how to use this tool, because it is an open source project, and open source projects tend not to have the best documentation. And so this is just kind of get you the foot in the door to make you think about how should I go about taking security scanning tools and putting them in our developer tools tool chain, and just having it scan and make sure that we actually get results and figure out whether or not what we're seeing from these tools is really something we should evaluate. With that, if anyone has any questions. So the question is, are you scanning on each commit or deployment time? And I'm going to be a consultant. It depends. Some of these tools, like linting or doing like these dependency checks, do them on every commit. It's really not that hard. The stuff like Zap, you have to spin up a web server. So whatever it takes you up to get that web server spun up, maybe that's a nightly thing. Maybe that is just something you run daily, or maybe that is, a check that you have before you actually say go live, or something like that. But those each one's going to have a little bit of variability, because Zap will be a little bit slower comparatively, because it's going to have to spin up your website, run against all these things, do all this stuff, and that might take 10 minutes. You probably don't want to report whether or not your code can compile in 10, 20, 30 minutes, if not even longer. But, bang out the scan and say, hey, do all my dependencies have problems? Yes, no? And it took 2 minutes. Is that worth it? Maybe. Anybody else? Can't really see too easy. This has got over here. So the question is, will this tool allow you to run the tests that you write custom tests for? So I'm guessing, like, if you write custom specific tests in Zap, you'll probably want to run those. As long as you can access those from this tool, yes. And there's other tools that you can write it for. Like this guy I know specifically talked about Gauntlet in the past, and so you could actually write tasks for Gauntlet if you wanted to. They don't have support specifically. They don't have support specifically for it, but you could write it into this tool. Anyone else? Sure. Okay, so the question is, would you run this tool if you have a system where you're using pull requests or merge requests to take in new code? Would you run this tool before or after? And I would say, again, it's that depends thing. It's probably run it before, because you know what? Anytime it's a merge request, to me, it's code that's going to be committed into master or active branch, whatever you want to call it, and you're going to want to say, this should check against all this stuff. And you may end up with the same things that your master branch has, or whatever that thing that you use to deploy to prod. You're going to want to just scan it. I think you should scan it along. And so don't even get to your code review, because you know what? If you get all those things, at least you know what to code review. Even if it isn't code review specific, you can actually look and say, these are the things that we're going to have to work on, because maybe this added a new dependency to some other module, or whatever. And so it's good to know that before you even have to look at the code. Anyone else? All right. Thank you very much.